an endless ocean of stars, countless galaxies stretching into unimaginable distances. So many scientists reasoned the galaxy should be teeming with them. So, as we continue to listen to the quiet heavens, perhaps the more pressing question the Fermi Paradox poses is not just about them, but about us. Faced with this profound cosmic silence, what kind of civilization will humanity choose to become? And what message, if any, will our own brief existence ultimately whisper into the vastness of time? We should see signs, hear whispers, detect their grand engineering. Megastructures, beacons, perhaps even probes in our own solar system. Yet when we look and listen, we find only silence. An unnerving, profound, and deeply unsettling cosmic quietness permeates all. This stark contradiction is known as the Fermi Paradox. Where is everybody? The question echoes in the empty void. The numbers suggest a crowded universe, full of intelligent life. But the reality we observe is starkly, eerily different. Is our understanding of life's emergence fundamentally flawed somewhere? Each star a sun, many with planets orbiting in silent ballet. Or is there some great, silent filter awaiting all civilizations? Perhaps intelligence itself is far rarer than we currently imagine. Or maybe advanced societies inevitably turn inwards or transcend detection. The silence could be a warning, a lesson, or simply data. It forces us to confront our own assumptions about the universe. What if we are among the first, or even utterly alone? The implications of that solitude are truly staggering to contemplate. Does the cosmos operate by rules we have yet to grasp? Is there a cosmic speed limit to expansion or communication? Or is the silence a reflection of something about intelligence itself? Billions of worlds, potentially trillions, existing within our galaxy alone. Perhaps all advanced technological species inevitably face self-destruction. This great filter could be a chilling answer to the silence. If the filter is behind us, humanity is exceptionally rare. If it lies ahead, our future is precarious and uncertain. The paradox isn't just about them, it's fundamentally about us. It challenges our anthropocentric view of significance in the cosmos. Are we a fleeting anomaly, or a seed for future galactic life? The silence holds up a mirror to our own potential. It reflects our greatest hopes and our deepest, darkest fears. It compels us to ask, what is our trajectory as a species? The raw ingredients for life are common, scattered throughout the cosmos. The search for others becomes the search for understanding ourselves. The Fermi Paradox, named after physicist Enrico Fermi, presents a profound enigma. Given the sheer scale of the universe, billions of galaxies, each with billions of stars, many likely hosting Earth-like planets, and the billions of years the universe has existed, life should have arisen and developed into detectable technological civilizations countless times over. The statistical probability seems overwhelmingly high. Enrico Fermi famously posed the question during a casual lunchtime conversation in 1950. But where is everybody? This simple query cut through complex astrophysical and biological assumptions, highlighting the glaring discrepancy between high estimates of the probability of extraterrestrial intelligence and the utter lack of observational evidence. No confirmed signals, no visits, no megastructures, just an echoing cosmic silence. The Drake equation, formulated by Frank Drake, attempts to quantify the number of detectable civilizations in our galaxy. It multiplies several probabilistic factors: the rate of star formation, the fraction of stars with planets, the number of habitable planets per system, the fraction where life arises, the fraction where intelligence evolves, the fraction that develops detectable technology, and the lifespan of such civilizations. Even with conservative estimates for many of these factors, the Drake equation often yields results suggesting thousands, if not millions, of civilizations should currently exist in the Milky Way alone. If even a small fraction of these decided to explore or colonize, they could theoretically cross the entire galaxy in a time frame much shorter than the galaxy's age. Yet, we find no trace. This leads to the Great Filter hypothesis. This theory suggests there's some incredibly difficult step or barrier in the long chain of development from simple life to an interstellar civilization. This filter could be something that makes the initial emergence of life exceedingly rare, or the jump to complex intelligence nearly impossible, or it could be a challenge that all advanced civilizations face and fail to overcome. If the great filter is behind us, meaning one of the early steps like abiogenesis or the development of multicellular life was incredibly improbable, and we were just extraordinarily lucky to pass it, then humanity might be one of the very first, or even the only intelligent species in our galaxy. This is a sobering thought, placing immense significance on our existence. However, if the great filter lies ahead of us, the implications are far more ominous. It could mean that a common developmental stage for technological civilizations leads to self-destruction, perhaps through nuclear war, ecological collapse, uncontrolled artificial intelligence, or some other unforeseen catastrophe. The silence of the cosmos would then be a graveyard, a warning. Another set of explanations revolves around the idea that life itself, or at least complex intelligent life, is exceptionally rare. The rare Earth hypothesis posits that Earth-specific conditions, its stable orbit, large moon, plate tectonics, magnetic field, and precise chemical balance, are the product of an improbable series of cosmic coincidences, making planets like ours exceedingly uncommon. Similarly, the evolution of human-level intelligence might be a fluke, a one-off evolutionary accident rather than an inevitable outcome of life. Countless species have thrived on Earth for millions of years without developing advanced technology or abstract thought. Perhaps the specific evolutionary pressures and pathways that led to human intellect are not easily replicated elsewhere in the cosmos. Given enough time, life should emerge, a natural cosmic process. Then there are hypotheses suggesting advanced civilizations do exist, but we simply cannot detect them, or they choose not to interact. The zoo hypothesis speculates that Earth is deliberately isolated, observed like a nature preserve, with a strict non-interference policy from more advanced cosmic cultures, a kind of prime directive writ large across the galaxy. Alternatively, their technology might be so advanced it's unrecognizable to us, or they communicate in ways we can't comprehend. Perhaps they've transitioned to non-physical existence or inhabit dimensions beyond our perception. Their motivations could also be utterly alien. They might have no interest in a young, noisy species like ours, much as we pay little heed to an ant colony. Some propose we might be among the first civilizations to arise. The universe, while old, might only now be reaching a stage where conditions are broadly suitable for technological life to emerge widely. If this is the case, the silence is simply because there's no one else older or significantly more advanced than us yet. We are the cosmic pioneers. The most straightforward, and perhaps most unsettling, explanation is that we are simply alone. Or, if not entirely alone in terms of simple life, then alone as a species possessing self-awareness, technological capability, and the drive to question our place in the universe. This solitude would redefine humanity's role and significance in the grand cosmic narrative. Regardless of which, if any, of these hypotheses is correct, the Fermi Paradox forces a profound philosophical introspection. The cosmic silence, whether empty or merely unperceived, acts as a mirror. It reflects our deepest anxieties about our future, our most cherished hopes for significance, and our fundamental assumptions about life and intelligence itself. If we are truly alone, or among the very first, it bestows upon humanity an extraordinary responsibility. Our actions, our choices, our very survival would then carry not just terrestrial, but potentially galactic significance. We would be the sole custodians of consciousness, the universe's only known way of observing and understanding itself, at least in this vast sector of space and time. This perspective could galvanize us to overcome our self-destructive tendencies, to cherish and protect the fragile biosphere of our planet, and to strive for a long-term, sustainable civilization. The silence could be interpreted not as an absence, but as a call to rise to our unique potential, to become worthy of the immense cosmic lottery we seem to have won. Conversely, if the silence implies that advanced civilizations inevitably destroy themselves, the great filter is ahead, then it serves as a stark warning. It compels us to identify and mitigate existential risks with utmost urgency. The ghosts of failed cosmic civilizations would be whispering caution, urging us to learn from their presumed mistakes before we repeat them. The Fermi Paradox also challenges our anthropocentrism. We tend to assume that intelligence like ours is the pinnacle of evolution, and that other advanced beings would share our drive for exploration, communication, and perhaps even conquest. But what if these are merely human, or even mammalian, proclivities, not universal traits of advanced consciousness? Perhaps truly advanced intelligence transcends such restless expansionism, focusing instead on internal development, virtual realities, or a harmonious existence within their local environment that leaves little detectable trace across interstellar distances. Their silence might not be absence, but a form of highly evolved contentment or a different mode of being entirely. And where life arises, intelligence could eventually follow its path. This possibility suggests that our current metrics for success as a civilization, technological prowess, outward expansion, resource consumption, might be immature or even misguided from a cosmic perspective. The silence could be an invitation to redefine progress, to consider paths of development that prioritize sustainability, wisdom, and inner richness over outward display. The search for extraterrestrial intelligence, therefore, becomes deeply intertwined with the search for self-understanding. As we scan the silent skies, we are also scanning the depths of our own nature, our potential, and our possible futures. Each null result, each unanswered call, forces us to look inward with greater scrutiny and perhaps greater humility. The very act of contemplating the Fermi Paradox expands our imaginative horizons. It pushes us beyond immediate, terrestrial concerns and connects us to the grandest scales of space and time. This cosmic perspective can be both humbling and inspiring, reminding us of the vast unknown and the potential wonders or terrors it might hold. It also highlights the preciousness and fragility of what we currently possess. If intelligence and technological civilization are indeed rare, then our Earth, our biosphere, and our shared human culture become infinitely more valuable. The silence underscores the irreplaceability of our world and the critical need for its stewardship. The Fermi Paradox encourages critical thinking about evidence and assumption. The absence of evidence for extraterrestrial intelligence is not necessarily evidence of its absence entirely, but it does demand rigorous examination of our search methodologies, our biases, and the limits of our current understanding of physics and biology. Perhaps we are looking for the wrong signs, or listening on the wrong frequencies. The universe might be communicating in ways that are currently beyond our technological or conceptual grasp. Like trying to understand whale song with only human language, we might be missing the true nature of cosmic dialogue, if any exists. The paradox also reminds us that civilizations are likely not static. They evolve, they change, and perhaps they transcend. A civilization billions of years older than ours might have moved beyond physical forms, energy signatures we can detect, or even the confines of this universe. Their silence could be the quiet of a radically different state of being. Consider the estivation hypothesis, which suggests that very advanced civilizations might enter long periods of dormancy, perhaps to await a cooler cosmic era more conducive to computation, or for other unfathomable reasons. They might be out there, but effectively asleep, waiting for a distant future epoch to reawaken. Ultimately, the Fermi Paradox is a question mark suspended over humanity's understanding of its place in the universe. It challenges us to grow, to learn, to explore, and perhaps most importantly, to reflect. The silence doesn't provide easy answers. Instead, It provokes ever deeper and more crucial questions about who we are and what we might become. The pursuit of an answer to the Fermi Paradox is not just an astronomical or astrobiological endeavor. It is a profoundly humanistic one. It engages our curiosity, our intellect, our philosophical traditions, and our artistic imaginations, forcing us to confront the limits of our knowledge and the vastness of our potential ignorance. Civilizations might then develop, reaching for the stars themselves. It reminds us that science is a process of ongoing inquiry, not a fixed set of doctrines. The paradox highlights areas where our current theories may be incomplete, or where entirely new frameworks might be needed to understand the universe and our place within its silent, sprawling expanse. Perhaps the silence is not empty, but full of lessons tailored to a species at our particular stage of development. It might be a cosmic koan, a riddle whose contemplation is more important than its solution, designed to foster introspection, humility, and a deeper appreciation for the delicate miracle of conscious existence on our small world. The paradox underscores the importance of long-term thinking. If civilizations have finite lifespans, and if interstellar communication or travel takes millennia, then our current short-term focus as a species may be insufficient to ever make contact, or even to ensure our own enduring survival long enough to be part of a galactic community. This challenge to think in cosmic timescales can inspire us to build legacies that last, to invest in knowledge and infrastructure that will benefit distant future generations, and to cultivate a sense of responsibility that extends far beyond our individual lives or national borders. It's a call for planetary and even species-level maturity. The Fermi Paradox can also fuel our drive for exploration, not just for them, but for knowledge itself. The search, even if it yields only more silence, expands our understanding of the universe, refines our technologies, and deepens our appreciation for the conditions that make life possible here on Earth. Each new exoplanet discovered, each new insight into astrobiology adds a piece to the puzzle. Furthermore, considering the fragility of our own civilization in light of potential great filters can foster a greater sense of unity and shared purpose among humanity. The common threat of existential risk, or the shared wonder of our potential uniqueness, might transcend petty conflicts and encourage global cooperation on an unprecedented scale. What if the silence is simply a matter of scale and timing? The universe is vast, and civilizations might arise and fall like flickers in cosmic history, too separated by space or time to ever overlap. We might be like two people shouting across an immense, stormy ocean, their voices lost in the roar of the waves and the vastness of the distance. The philosophical weight of the Fermi Paradox lies not in any single proposed solution, but in the persistent, uncomfortable nature of the question itself. It is a constant reminder of the limits of human knowledge and the profound mysteries that still envelop our existence. It keeps us humble before the immensity of the cosmos. This humility can be a powerful catalyst for growth. Recognizing our potential cosmic insignificance, or alternatively, our potential cosmic rarity, can strip away arrogance and foster a deeper sense of wonder and responsibility. The silence encourages us to define our own meaning, rather than expecting it to be handed to us from the stars. The Fermi Paradox, in essence, is a story we tell ourselves about our place in the universe. The characters in this story are hypothetical aliens, great filters, and humanity itself. The plot is the grand sweep of cosmic evolution, and the moral of the story is one we are still trying to decipher, written in the silent language of the stars. They would populate their systems, perhaps even crossing interstellar voids. Whether the galaxy is a bustling metropolis hidden from our view, a vast wilderness awaiting its first settlers, or a cosmic graveyard whispering warnings, our response to that perceived reality shapes who we are. The silence is a canvas onto which we project our fears, our hopes, and ultimately, our understanding of ourselves. The paradox reminds us that intelligence may not automatically equate to wisdom. The capacity for advanced technology does not guarantee its benign use or the long-term survival of its creators. The silence might be the sound of countless technological species failing to make that crucial leap from cleverness to true, sustainable wisdom. Our own history is replete with examples of civilizations rising and falling, of knowledge gained and lost. The Fermi Paradox scales this drama to a cosmic level, asking whether this pattern is an inescapable fate for all intelligent life, or whether some find a way to break the cycle and achieve enduring stability. This makes the choices we make today regarding climate change, resource management, global peace, and ethical technological development not just important for our immediate future, but potentially resonant with the grand, silent narrative of the cosmos. Are we writing a story of survival and transcendence, or another chapter of eventual silence? The search for an answer to "where is everybody?" is, in many ways, a spiritual quest disguised as a scientific problem. It touches upon ultimate questions of meaning, purpose, and our connection to the universe. It is a modern manifestation of humanity's age-old desire to understand its origins and destiny. Each generation reevaluates the Fermi Paradox in light of new discoveries, exoplanets, extremophiles, deeper understanding of cosmology. Yet the core mystery endures, adapting its philosophical sting to the knowledge of the times. It remains a potent intellectual catalyst, driving both scientific inquiry and profound self-reflection. Perhaps the solution to the Fermi Paradox is not a single, neat answer, but a complex tapestry of contributing factors. Maybe life is rare, intelligence rarer still, civilizations are fragile, and the universe is simply too vast for easy encounters. The silence could be the result of many hurdles, not just one great filter. This perspective doesn't diminish the philosophical weight, but rather deepens it, suggesting that our existence is the outcome of a truly extraordinary series of fortunate events and successfully navigated challenges. It makes our present moment, and our future choices, seem even more precious and pivotal in the grand scheme of things. The silence of the universe challenges us to become better listeners, not just for hypothetical alien signals, but for the subtle signals from our own planet, from each other, and from the quiet voice of wisdom within. Perhaps the first step to understanding our place in the cosmos is to truly understand and heal our place on Earth. If we are to one day break the cosmic silence, or understand its meaning, it will likely require a civilization that has achieved a high degree of internal stability, empathy, and long-term vision. The Fermi Paradox is thus not just an intellectual puzzle, but a moral and developmental challenge for humanity as a whole. The universe is ancient, providing ample time for such spread. The paradox teaches us that assumptions can be dangerous, especially when scaled to cosmic proportions. Our human-centric biases about what intelligent life should do or how it should behave may be entirely misleading us in our search and in our interpretations of the silence we perceive. Therefore, a crucial part of engaging with the Fermi Paradox is cultivating intellectual humility, an openness to possibilities that currently seem outlandish or counterintuitive. The universe has surprised us before, and it will likely continue to do so as our knowledge expands. What if the signal we are waiting for is not a radio wave or a laser pulse, but something far more subtle? Perhaps it is embedded in the very fabric of physics, in the patterns of cosmic evolution, or even in the nature of consciousness itself. A message only decipherable by those who achieve a certain level of understanding or awareness. This line of thought pushes the paradox into more esoteric territory, suggesting that the universe might be a far stranger and more deeply interconnected place than our current materialistic science fully grasps. The silence could be a veil, obscuring realities that require a different kind of perception to access. However, even within more conventional frameworks, the implications for our own species are profound. The responsibility to survive, to learn, to grow wiser, and to act as responsible stewards of our planetary home becomes paramount, whether we are alone or simply haven't yet found the cosmic neighborhood. The Fermi Paradox is not a counsel of despair, but a call to action, and equally, a call to reflection. It asks us to consider what kind of ancestors we want to be for future generations of humanity, and what kind of species we would want to represent Earth, should we ever make contact with another intelligence. It urges us to explore the full spectrum of our human potential, our capacity for scientific discovery, philosophical insight, artistic creation, and profound empathy. These are the qualities that might not only ensure our long-term survival, but also make us a species worth encountering, or a species capable of truly understanding the cosmic silence. The silence of the universe, therefore, is not an empty void but a resonant space. It echoes back our own questions, reflects our current state of understanding, and challenges us to fill it not with noise, but with wisdom, with purpose, and with a deeper appreciation for the improbable gift of our own conscious existence. In summary, the Fermi Paradox, the stark contradiction between the high probability of extraterrestrial life and its apparent absence, serves as one of the most powerful intellectual and philosophical catalysts of our time. It forces us to confront our assumptions, our future, our potential fragility, and our cosmic significance, or lack thereof. The key takeaway is not a definitive answer to where is everybody, but rather the profound realization that the question itself turns our gaze inward. The cosmic silence compels us to consider what it means to be an intelligent, technological species, and what responsibilities come with that, especially if we are rare or early or perhaps even alone.